Welcome to a lesson on Essentials of Circles. In this lesson, we'll be talking about circumference, area, sectors, and arcs. And there's a picture of a circle on the top right corner of your screen. I've drawn a line all the way across. I used my line tool and I sized it all the way down. That line represents the distance from edge to edge going through the center of a circle. That line is called the diameter. Then there's the line that goes from the circle's center to the edge. That distance is half the length of the diameter. We call this the radius. Hopefully these terms are going to ring a bell. You've had them in earlier grades. We're going to bring them back into your memory in this lesson. Now there's going to be some new terms. We know the distance all the way around the circle is called the circumference. But what if I wanted the distance around part of the circle? We call that piece of the circle an arc, and we call this part of the circle the arc length. So in this lesson, we're going to learn how to find the arc length. And what if I wanted the area of the entire circle? All the space inside a circle is called the area, but the area of this piece is called the sector area. So these are new terms that we will be looking at in this lesson. Let's go on to slide number 2. And we're asking you to draw or describe 2 real-life examples of circles. And every time I consider a circle, it always amazes me. Whatever room I'm in, even if I'm outside, if I'm inside the house, outside the house, out and about in a store, there are going to be circles everywhere. So right now I'm looking at my chapstick actually, and I see that there is a circle on the top and bottom of my chapstick. So I could try to draw that. I could also describe it in words. I've got a circle on the top and bottom of my chapstick. Always fun to find circles. They literally are everywhere. And this chapstick has a circular top and bottom. There's so many more circles. So looking forward to seeing what you come up with for both real life examples. Let's move on to slide number 3. We're going to be reviewing terms. In math, it's as in every subject. It's really important that you are familiar with the vocabulary. So I was going to give you a word bank, but I wondered if you would be able to come up with these definitions and just based on memory. So what is the line segment that goes from edge to edge and passes through the center of a circle called? Picture a circle, picture a line segment that passes through the center. That is your diameter. Now, half of that distance, the distance from the center to the edge of a circle, that is your radius. How about the distance around the outside of a circle, the length around, kind of like the perimeter, but of a circle? We call that the circumference. Circumference. The space inside of a circle measured in square units is the area of the circle. And the ratio of the circumference of any circle to its diameter, this is the number pi. You'll notice I said the number pi. Pi is not a variable. It is a number. It is a special number. We call it an irrational number because the digits of pi go on forever. The decimal part of pi goes on forever. Those digits do not repeat. There is no pattern. This is one of the most famous irrational numbers of all. It rounds to the number 3. But it's close approximation is 3.14. That's typically what we use to approximate pi. There's also going to be a pi button on your scientific calculator. And the pi button is here. And those digits, if we had more spaces in our calculator, we would see more digits. All right, let's keep going on with our lesson to slide number 4. 2 problems to solve. The first one says, given the circumference, find the area. So we know the circumference of this circle is given as 26 pi feet. And we're asked to find the area in square feet. So what we're going to do is use your grade 10 math MCAS reference sheet. And we're going to look for the formula for circumference. There it is, C equals 2 pi r or C equals pi d. Either one of those formulas are valid. The formula for the area of a circle is pi r squared. These go back to earlier grades. So in this particular problem, it's saying the circumference is given as 26 pi. What is the area in square feet? We're going to use either formula for circumference and then use the formula for the area to solve this problem. Now pay attention to the fact that the directions say express your answer in terms of pi. Really important you know what that means. These directions mean your answer should have a pi in it. So we are not going to replace pi with 3.14. Neither are we going to actually use the pi button on our calculator. We're going to completely not use the pi button on our calculator. Now, we're going to take a look at what's given. What's given is information about the circumference, so bear with me. The circumference is given as 26 pi. So I started with my formula for circumference, pi, and I used pi times diameter. I substituted 26 pi in place of c, and I wrote 26 pi equals pi d. I notice there's a pi on both sides of the equal sign. Now pi is a number. I can divide both sides of an equation by the same number and still have a valid equation. That tells me that 26 is equal to my diameter. From there, I can find my radius by dividing by 2. I know my radius is 13 feet. Now, how does that help me find the area? Well, the good news is if I know my radius, that's part of my formula, I can just do what the formula says to do with the radius, square it and multiply by pi. So that's exactly what I want to do. I want to start with my formula for the area of a circle. I want to substitute my radius of 13 feet and square that radius. When I square the number 13, I get 169. I am not going to square pi. I'm not going to put pi into my calculator. I'm going to leave my answer as 169 pi. And remember, we're going to also square the units, which is why area should be in square feet. Now over here, we're saying given the area of a circle, find the circumference. So the area is given as 121 pi square inches. Let's start with the formula for the area of a circle. Let's write that down. And then let's substitute in the area that's given in place of A. So here's my formula for area. I'm going to substitute what's given for A. And I'm going to do the same thing as last time. Observe that there's a pi on both sides of the equation that I can divide both sides by pi, simplifying my equation to 121 equals r squared. Now we want to solve for r. So we're going to undo squaring r by taking the square root of both sides. And the square root of 121, a calculator can help us, or maybe you know your 11s tables. The square root of 121 is going to be 11. So my radius is 11. Okay, how does that help me solve the problem? They want to know the circumference in inches, and again, writing my answer in terms of pi. So I start with the formula for circumference of a circle, but this time I'm going to be more strategic. I'm going to use the formula that involves radius because I know the radius. So I'm going to start with C equals 2 pi r. From there, I'm going to multiply 2 times pi times my radius, which is 11 inches. And I'm going to simplify the right-hand side of this expression, but I am not going to deal with the pi. The only thing that I would type into a calculator if I had to were the numbers. 11 times 2, that's 22. I can do that with mental math. So my answer is circumference equals 22 pi inches. Hopefully these concepts are coming back to you from earlier grades. I believe it was 7th grade that you would have gone between circumference and area of circles. All right, let's go on to the next slide, number 5. This is an application problem. The title of the problem is Baseball Stadium. The shape of an outfield fence in a baseball stadium is that of a quarter circle as shown. So this green part is the fence, outfield fence. The distance from home plate to the wall is 330 feet. So I'm interpreting this right here as the radius of the circle, okay? And it's saying, what is the radius of the circle? Well, that's given as 330 feet. So then it says, what would the circumference of the whole circle be, right? When we talk about circumference, we're talking about the circumference of the whole circle. Otherwise, we would use the word arc length. So the circumference of the entire circle would be found by using the formula. I chose 2 pi r because I have the radius. I substituted the radius of 330 feet in place of r, and I just multiplied 2 times 330 to get 660 pi feet. So all the way around would be 660 pi. Now it says, how long is the curved outfield fence? So how long is this green piece? Well, this green piece, because it is a quarter circle, think about what we mean by quarter. Quarter means 1/4, right? So we want so all the way around a circle is 360 degrees. This has got to be 90 degrees, right? This is 1/4 of the circumference. So when we want to find the length of this curved fence, it's going to be 1/4 the circumference of the whole thing. And we know it's 1/4, one more time, because it says it's a quarter circle. So with our calculator, what's 1/4 times 660? And it does say leave your answer in terms of pi. Always check those directions. So 1/4 times 660, times 660 is 165 pi feet. So that's the length of this curved part. Now, the last question says, what is the approximate area of this shaded region? Well, we've already talked about the fact that it's 1/4 of a circle. So let's make a plan. What if we found the area of the whole circle? How could I take that answer and adjust it to get the area of the shaded region? The area of the whole circle, if I found that, I could divide that by 4 to get the area of the curved region. So that's exactly what we intend to do. Let's start with the formula for the area of a circle. A equals pi r squared. Now let's go ahead and substitute in the value for I'm trying to do my keyboarding shortcuts here, and it's not allowing me to do that. So I almost have to copy pi from this and then paste it down here. Okay, there we go. So we're going to substitute in the value of radius. So the area of the whole circle is pi times 330 squared. But I want the area of the shaded region, right? So whatever 330 squared is, I want to divide that by 4 to get the area of the shaded region. I'm going to do 330 squared. And I'm going to divide that by 4. And it's going to be 27,225 pi square feet. Now the last slide is just something in 1 minute. Write something down that you want to remember from this lesson.